Good morning, dear students. Welcome to another session of Verilog HDL. So, in previous sessions, we discussed regarding gate level modeling, and then we came down to data level modeling, and we saw how both are different and which one is easier to go around when we are dealing with the complex circuitries. And now, even in the previous case, we saw that we could design the say a circuit using its logical expression or using some control say a controlled sorry, conditional operators, using conditional operators. So we saw these things. But even then, if the circuit complexity keeps on increasing, it becomes a tedious process to go around with say modeling such kind of circuits. So what is the other way to move around so that you can forget about what is present in the lower end, that is how the gate level implementation is done, how the data flow modeling is done. You're not bothering about that. So in order to do that, we go for behavioral level of modeling. So that is behavioral abstraction. This is the highest level of abstraction which is present in your Verilog. So what what is advantages regarding this one is it for the designer, what happens is he need not bother about how the lower level implementations are going around, what is happening over there. So, for example, in gate level modeling, you are specifying as to say you have to instantiate the gates. So, if you want to instantiate a AND gate, what you specified it as AND. Then whatever is the name of that module you want to give, you give the instantiation name. Then you put down the parameters or the port list, that is the what is the output and what are the inputs related to those gates, and then you have to specify how they are interconnected, these all things. So such kind of things is not required in your behavioral level of modeling. So in short, if I just have to tell if I have to just specify behavioral level of modeling, it is somewhat similar to writing program in your C programming language, which is a high level language, but you are dealing with your hardware aspects, that is how the hardware behaves, that is what you are taking care in these things. So in your hardwares you might have observed that if you're having say IC, if you're having a IC, now if you give some two signals at a time, so this is possible simultaneously. I can apply two signals and simultaneously I can get a number of outputs. So it is like concurrently you are applying, and concurrency can be observed even in the output. So these are some special things what we have to take care when we are dealing with hardware. So such kind of facility should be provided in your Verilog HDL. In C programming, what happens is it is sequential. That is, after first line is executed, then the next line. After that, the next line. So this is how it goes around. So that is what makes this Verilog HDL different in behavioral level modeling with respect to the other high level say languages what I can specify. So and this has to deal with the say hardware aspects. So Verilog itself has to deal with the hardware aspects. So we'll be looking into a few of the concepts related to behavioral level of modeling in these cases. So these are just a few objectives what you can just go through when we are dealing with the entire behavioral level of modeling. So we'll be dealing with something termed as initial and always behavioral modeling specifications, then blocking and non-blocking procedural assignments. So then there are some aspects related to the delays. So these are just a few things what we'll be discussing around. Okay. So even in your C programming, you might have seen if else case statement. So here additional is case X and case Z. So these looping constructs. So then we come across a few parameters which is sequential and parallel blocks. So this is another one feature of Verilog HDL. So then these are just a few things to go around. So we'll start off with structured procedures. So basically there are two structured procedures which are present in Verilog, which are specified by always and initial. So there will be two structured procedure statements which are present in Verilog. The name itself, they can specify that something has to be done in continuously. It has to be done continuously. And initial specifies that it has to be done okay at only once at the initial stage. So we'll see what it actually means over here. So these are the most basic statements in your behavioral level of modeling. Now here, if we just look out the first one, that is initial statement. Now here what happens is whatever statements are present within this initial statement, or whatever code is present within this initial statement, will be executed only once. So first this thing is the all the statements which are within the initial statement will be executed only once. So that is the first thing. And another important thing to note down is you can have multiple initial statements. You can have multiple initial statements. So we'll be looking at examples of these. Now, whenever you start up the simulation, this simulation starts at say time t is equal to, it starts at t is equal to 0. So initial statements, whenever you start up the simulation, the initial the statements which are present within the initial statements also start their execution, or also give their result at time t is equal to 0. That is what happens is we'll just look with respect to example related to this. So first thing, all statements within the initial statement constitute the initial block, and initial statements are executed only once. They are executed only once in the entire simulation. Then initial block starts at time 0. That is what I was trying to specify over here. So let us look at examples and then we'll be clear regarding these things. And we can have say instead of just one statement within the initial statement, we can have n number of statements within an initial statement. So in order to do that, we should use something called as begin and end keywords. So which act as the open and close braces in your C programming. So they act in that form. Suppose you have a main program. If you want to have n number of statements within that main statement, you have to put those in the curly braces. So that is what you're doing. So even in initial statement, you can have n number of statements present over there, and those n number of statements, if they have to club into, they have to be clubbed into one initial statement, then they have to start with begin and end. So let us see with an example. So this is the example related to initial statement. So you have modulus stimulus, and this there is no port declaration or port list available. Here you have the port declaration which is being done, but whether it is output, input, so those all things will be coming around. So here we have the first thing, that is initial. So this is a keyword. This is a keyword. So this keyword is utilized to specify or identify the initial, the all the statements which are present in that initial block, which are present in this initial block. So in this one, what is happening? You have initial and you have one statement over here. So this initial is having only one statement. So it is m is equal to 1 bit, which is equal to 0. So this is just a single statement within a initial this thing, initial block. So now so it is like you have initial and you have one statement over here which is specified as 0. So this is entirely one. This is a, this is initial block. Now this contains only one statement. Now if it has to contain more than one statement, that is multiple statements within this initial block, then I have to use begin and end keywords. And within this, I can have another statement. I can have another statement. So this is how you put multiple statements within the initial statements. So this is the first example wherein only one statement is present within the initial block. Within the initial block. Now here we can see that we have initial, begin and end. So it is like you are writing, say, for loop or anything in your C programming, and if you have n number of statements within that for statement or for block, then you have to put it in curly braces. So it is something in that form. So initial, begin, and end. So all these statements belong to this initial block. This initial block. So similarly, we have another initial block which is specified here. It is begin and end. Begin and end. And here we have two statements which are present within this initial block. Now, from this one, what you can identify is, in order to specify initial block, we have to use the initial keyword. If you have to specify initial block, we have to use the keyword which is initial. And if there is only one statement within this initial block, then no need to use begin and end. Even if you use, it is not a problem. There is, but no need to use begin and end if only one statement is present in this initial block. If you have more than one statement to be put within the initial block, then what you have to do is you have to use the keyword begin and end after the initial keyword what you are using, and you can have a number of statements over here. Now in this case, what is happening is you have three initial blocks, one having single statement and two having multiple statements. So that is this part and this part. Now in this one, and here there is another one which is having only one statement, which specifies that after 50 time minutes you have to finish the simulation. Now here, how does this run around? So how does this move around? How does the execution happen now? Now, for example, now we have three initial statements, right? So for example, what I'll do is, this is for the first one I'll just consider, which is having single statement. This is the second one, and this is the third one. Now, what happens is when you start off with the simulation, all the blocks, initial blocks, that is this block, and this block, start off at time t is equal to 0. That is, at t is equal to 0, all the initial blocks start off. That is the first, second, and third. Now, in the first case, if you just see, it is just specified as m is equal to 1 bit, which is equal to 0. Now, what happens is, since there is no delay specified over here, so m will be assigned a value at time t is equal to 0. That is, at t is equal to 0, in this part, at t is equal to 0, m will be assigned a bit 0. M will be assigned a bit 0. Even this also will start, but here if you just see, there is no statement which is having something in this form. For example, if I had a statement, so if I have to just take an example, if I had a statement as specified n is equal to 1 bit, which is equal to 1. So, and there is no delay specified. That is, I am writing it as n is equal to 1 bit, which is equal to 1. And this one, I am correlating it to the second block. I'm correlating it to the second block. That is, this statement is present in the second block, and there is no delay specified. So what happens is at time t is equal to 0, even here the execution happens and n will be assigned a value 1. So what is happening? Concurrency occurs in initial blocks. Concurrency occurs in initial blocks. That is, all three blocks start their execution at time t is equal to 0. So all of them start the execution at same time. So this is what concurrency applies. So remember, this is one of the important features in your initial statements. So I am having three initial statements, three initial blocks. So all the blocks, when I start the simulation, all the initial blocks will start their execution at time t is equal to 0. Here, what happens is this second initial block will not be waiting for this to finish. So if I have 100 statements in this, it will not be waiting for this one. So this also will be happening, and the others also will be happening. So it will be in going in parallel. Now here, if you just observe, so in this one I have just only one statement. So m is assigned at t is equal to 0. But now if I just check over here, I have hash 5 a is equal to 1. So what happens is after 5 time units from the start, that is from t plus 5 time units, say somewhere here. So somewhere here. So after 5 time units, what happens is since it is present in over here, A will be assigned a bit 1. A will be assigned a bit 1. Now here you can see that it is hash 25 and B is assigned a value 0. So from here somewhere I'll just assume that it is somewhere here, that is it is 25 over here, from that is from this point to this point it is 25. So after 25 time units, that is total is 25, not from this point, it is from t is equal to 0, when after 25 minutes of time is being passed. So at that point what happens is b will be assigned its value, so that is b will be assigned 0. So now if I come to this one, right, initial, you can see that after 10 time units, x has to be assigned a value of 0. So all the blocks have started at t is equal to 0. All the blocks have started at t is equal to 0. Now after 10 time units, x has to be assigned. So from this point, say if 10 time units is somewhere here. So if 10 time units is somewhere here. So at this moment, what happens is x will be assigned its value. So then again, after 25 time units, y is assigned 1. So from here to here, 25 time units, it will be assigned 1. So that is what they are specifying. Oh, sorry, I did one mistake over here. So please rectify that. I did one mistake over here. So this 25, what I have specified, right? It is from this time unit. Sorry, now we have to consider the previous value. That is here we have 5. So from 5 time units, A is assigned value. Then next to 25 time units, that is 25 plus 5. At 30th time unit, B will be assigned a value. 30th time unit, B will be assigned a value. So similarly, when we come down to here, this initial block has started at t is equal to 0. So after 10 time units, x will be assigned a value and plus 25 after this. So it will be 35 time units, y will be assigned a value. So please rectify that one. So if I have to just specify it again, so this is first initial block, this is second initial block, this is third initial block. So in a first initial block, what do you have? So you have started with the execution. All the initial blocks start at time t is equal to 0. All the initial blocks start their execution. Now in this one, I have only one statement and there is no delay specified. So at time t is equal to 0, m will be assigned a value. That is at this point, m will be assigned a value. Now, at the same time, t is equal to 0, this initial block also begins its execution. So if I just see, after 5 time units from t is equal to 0, a will be assigned a bit 1. So let us assume that, say, so it has started over here. Say at 5 time units, here a is assigned a value. Here m was assigned, here a is assigned a value. And plus 25 time units after this one, that is from here to plus 25. That is 5 plus 25, sorry, 30 time units, say b will be assigned a value. Now this initial block also starts at t is equal to 0. So it has started at t is equal to 0, but after 10 time units, x is assigned a value. So say 10 is somewhere here. So at that moment, x is assigned its value. Then plus 25 to this one. So from here to here, you add 25. So it is somewhere 35. So 35, after 35 time units, y is assigned its value. Now again, here we can see that we have initial hash 50. So what does uh, this do is it will terminate the it will finish off the simulation after 50 time units. This block also starts at, so this is your fourth initial block. So this block also starts at t is equal to 0. It starts off with the all the other it starts off with all the other initial blocks. So and when p is equal to 50, right, that time, that is from this point to this point, after 50 time units, the simulation is finished. So that is what is happening in these cases. So here a few things to note down is initial statements begin with the keyword initial, and the all the statements which are present with the initial this thing have to be put in between begin and end if there are multiple statements. If there is one statement, no need to use the keywords begin and end, such as the statement what we are seeing over here. Then apart from this, all the initial blocks all the initial blocks start at the same time, that is time t is equal to 0, and initial blocks are executed only once. Initial blocks are executed only once. So these are just a few things to note down. So the same this timing this thing is provided over here. So at time t is equal to 0, what happens? Statement m is equal to 0 will be executed. So that is what we have specified over here. That is at t is equal to 0. After 5 time units, what happens is, because this also starts over here, a is assigned a value. A is assigned, or this statement is executed. Then what is happening, which is the next statement which is executed? So if I just observe here, this statement. So at 10 time unit, X is executed. After this, what you have? You have statement which will be executed at 30 time units. And then 35 time units, Y will be initialized the value. And lastly, the finished statement, that is, which will be at the 50 time. So this is in association with the initial block statements, and we discussed about how initial blocks can be specified using the keyword initial. If there is one statement, how we can go ahead. If there are multiple statements, how we can go ahead putting those statements in the initial block. And what happens if multiple initial statements are present in the module. So all the initial statements begin their execution at same time t is equal to 0. So that is what is happening